welcome everyone to Robot Builders Night Virtual for Tuesday, February 25th. And we've got a couple of people in the queue, Ray and myself, and have some, I don't think there's much in the way of DPRG news, and then we'll go to open mic. DPRG news, I guess the important thing was we held a Saturday meeting, the February meeting on Saturday, and we had a quorum for the election for new officers. So I'm very super happy to welcome Mark and Eric Cheney to the board, and to so yay, thank you guys for volunteering, stepping up, and I want to thank Carl and John for their service on the board, and we appreciate you guys, and we'll move on from here. New blood, it's always a good thing, new ideas. Let's see, the only other thing that we got, I announced at the meeting that I think we're in good shape for the next few months worth of topics. This coming in March, I'm going to give a talk on Lino robot and ROS navigation. And then in April, we're going to have a sort of a moon day at the makerspace, an exhibit, robot run. We'll have to come up with some kind of name that is catchy, but show off our robots and drive them around and have fun with them, and exhibit them to whoever comes by to the Dallas Makerspace open house. And then so that's April. May we'll have Roborama, so that takes us through there. And then at the end of March we'll have another end of March we'll have another robot power lunch. Just let's see, from the people who are here and in the Metroplex area, who would prefer say a Sunday or a Monday? Last time we did a Sunday, but that was kind of in the holidays. Anyone preferences?
Sunday was good.
What?
Sunday was good for me, but I mean,
yeah.
See.
Okay. All right. I'll see if I can do it on Sunday. All right.
I like Sunday too.
All right.
IMHO.
Oh, you think you could make it out, Ray?
Possibly, yeah. Not on a Monday, but probably on a Sunday.
Oh, that'd be awesome. Okay, and then we are going to resurrect Roby, and so I'll show off some parts for him later. But we've got to figure out a time to get together. So maybe we can talk about that during when we get to open mic. Anyway, with that, let's kick off the queue. Ray, you're up.
Okay. I have been playing around with OpenBot stuff and got a few more things to work, but still can't get some things to work. One of the things that you can do is, you have to have one phone that goes on the robot, but you can actually have another cell phone control the robot if you want. It's got like two sliders on either side, and that seems to work, although it doesn't seem that reliable. I was kind of hoping, Tom, have you done anything more with no? Darn. Oh, there's another tie-in with this. The board that Doug designed during his KiCad presentation would be perfect for this because it's got an ESP32 on it and the TB6612 motor driver and two DC to DC converters for, I want to say for 5 volts and 3 volts or 3.3 volts. So the perfect board, I was actually thinking of maybe modifying his design. I kind of settled on a different ESP32 than he did, but pretty much the board I think that he designed would be usable as it is. I think you can get those that footprint to the ESP32. That's a pretty common one. I want to say it's I don't know if that was the 32 or the 36 pin footprint, but
The one on the board was a 30 pin.
it was a 30. Okay.
Yeah, because I figured, what's the heck with the 6? You're not going to be able to use them.
Yeah.
When we took it up to JCL, we found some errors. So the errors are probably when I was moving things around on placing things.
Mhm.
I must have changed some of the levels of some of the part names and stuff. So it's not horrible, but just don't anybody just grab that one and throw it out there.
Okay.
I'm gonna fix it, and it'll be put on post that's in the club post, so that project will be up to date and right.
And
Yeah, not going to do much work, but just a little bit. At least it would be a starting point.
And Ray, did you look at the WaveShare general driver for robots at all?
Did I?
Mm-hmm.
Or Doug?
Because it's the things that you listed as needing H-bridge, dual H-bridge driver, LiDAR interface, and the ESP32 are all on that board, and it's like $28. So it's fairly.
Oh, it's just $28. Oh,
yeah.
I thought it was more than that. That's not a bad price.
Let me just double check that, but I believe that's correct.
Okay.
Yeah, my biggest problem with that board is I don't like some of the connectors, and they waste some of the pins because they have to make it universal for their parts. Their robots, they have different, not all of their robots are ESP32s. How should I say that? No, that's not quite what I wanted to say. Not all the robots use the same type of motor driver. I think it is. So they have different types of motor drivers. I believe that's what's different. And anyway, there's nothing wrong with it. I mean, it's, for $28, it's not a bad driver at all. But, like the LiDAR, all that is going to be, a UART. So, I mean, that's not a big deal.
Yeah.
That's, the board I designed had the UART on it also. So it pinned out. But I'm not trying to promote one or the other.
Yeah.
They're both very usable.
Yeah. One of the things that this uses is apparently you can use Anaconda or Miniconda to set up like a virtual environment. And the version of what's it called? Python is for some reason it doesn't compile. I don't know why, but if you follow the steps and the instructions, it chugs along, looks like it's going to compile, and then it comes across an error, and so I'm not certain what that is. It could be maybe something in my setup, probably something I did wrong.
So Ray, where is the Python being installed on? What?
Oh, on my laptop.
On a laptop. Okay.
Yeah, and it's used to like if you're going to train models, using the phone on the robot.
Yeah.
To do whatever, follow something, navigate to a point. things like that, that's where you need to be able to do that. So
when you say you had a condo, a lot of times I think Windows. Are you trying to do this on a Windows laptop?
yeah,
Okay.
you can do it for.
Okay, I wouldn't recommend that.
You wouldn't.
No, I would say go either use, what is it, Windows for Linux 2, or use a virtual machine. It will be you'll be a lot happier.
Oh, okay. Well,
With
it
any
looks like they have
Python.
it set up for
Yeah.
Windows, Linux, or I guess iOS. So pretty much covers everything.
Yeah.
Hmm.
Every time
Anyway,
I try to work with Linux on a Windows machine, other than doing those things that I told you about, it's always, if I just to do it on a straight Windows machine, sooner or later it goes to, you know what. So I would, like I say, I'd either use Windows for Linux 2, or I'd use the, a virtual machine.
Yep. And even, let's see if I can present here. Present a window. And screen. Link. And let's see if that's going to work. Yep. Okay, there it goes. Oops, looks like I lost my connection. There it is. Okay, one of the things that is supposed to be pretty simple, they showed God, I don't know how old the little girl was, less than 10-year-old kid, uploading this. Let's see, I don't know if I'm still signed in. Yep, pre-signed in. I guess it timed out. Can you see that screen?
Yeah.
With the OpenBot Playground. Let me sign in. Gamma. Anyway, one of the things that you're supposed to do is hit the upload code button. It checks out your little code, segments. It's supposed to give you a QR code to scan. And just like that, it's supposed to download and, run on the phone that's on your robot. Doesn't do any of that. So don't know why that's not working. This wasn't anything that required installation. I mean, you had to set up some things on Google Drive, but other than that, it should have worked. So there's a couple things, and I may have done something wrong, but
it doesn't show you the code in the background. I mean, you can't click it and see what's going on in the background, the actual code.
Yeah, it does. Let's see. You get a couple choices you can get. I think in Python, yeah, there's the code in Python right there. So it's,
You stopped sharing, right?
Say that again.
You stopped sharing.
Oh, oops. Yep.
Yeah, it looks like they built that off of scratch, which is the same, actually, from processing, same IDE from processing.
Yep.
Hey, Ray, if you change something, when you change something, does the code change? I mean,
yeah,
it does. So how about the little scan code? Does that change too?
I guess I didn't look at the dots to see if it looked different.
Well, I don't know. It might, you're right. It might not be one of those things you could see, but if you could see it, it might. At least you'd know the part was trying to update.
Yep. Infinity window. Okay, yeah. Can you see that now?
Oh, yeah.
Yeah. Anyway, so it does it. I think it'll show it in both JavaScript.
If you change the speed from 192 to something different. We should see it in the text
Oh,
window.
yeah. Like if I scale that down,
Oh wow.
let's see,
Yeah.
did it change? Yeah, it changed.
Yep.
144.
Wow.
Scratch does a similar thing. So we've used
Wow.
Yeah.
little off-the-shelf robots, which did work. It required some kind of funky, like maybe not Windows signed drivers, but once you got past that, it actually did work pretty well.
Yep. Yeah, and this is, kind of an easy way to test things. You can put in different, as far as different AI models. Let's see here. Well, I don't know. This may not be set up for all those. It looks like, okay, I guess you can't choose it there.
Hey, Ray, if you change the Python code, does it reflect back into the other side?
Oh, I don't know. I hadn't tried it. Let me see here. Doesn't look like I can change it. Nope.
If I remember from the parent IDE that this seems to be based on, it actually lets you have some degree of modularity. So you could define functions and call them and pass parameters, and
Right.
you could actually get relatively complicated if you tried.
Yeah. And, this was, I guess, intended just to do simple tests to see whether, what you were going to try to do actually worked or not. But since I can't upload it, I can get it onto Google Drive, but the phone doesn't seem to know what to do with it. And so, like I said, I may have installed something wrong. But, oops, infinity window. So I'm hoping Tom is going to show all kinds of interest in this and try the same sort of, downloads and setups and all that kind of stuff. And
when it rises that high on my list, yes.
Say that again.
When that project rises high enough on my list.
Oh, okay. Yeah, I thought it was. That was kind of neat. In the show that. Oops, I don't want closed caption. Window. Share. Yeah, as far as the wrong one. Okay. Sensors, like these are some of the phone sensors that you can use: accelerometers, magnetometers, gyros. I don't have them all turned on right now, but you had access to GPS, you have access to the camera. I'm trying to think what other ones were in there. Let's see here. Oh, it might be in. No, I don't. I was going to say I thought it was in variables, but I don't think it is. Yeah. Okay. No. Anyway, so there's, I think, a little bit more than what that showed as far as things that you could access in the phone. And if, if the things in the phone are that much easier to access or maybe a little more accurate than some of the setups that we have, I thought that might be kind of a neat thing to look at or see or be able to use to guide the robot platform around. But anyway, so that's where I'm at.
So do you think it's a candidate for like Foursquare or Sixcan, or what are you thinking its use might be?
Yeah, I think it can. It kind of seems like, we could use, like for outdoor stuff. I was thinking about using the Max Cam. And it seems like it would have similar capability to the Max Cam for like something indoors, like to train it to find cans. And I think it could do that. It seems like with, just the different sensors on the platform, like on my last 6-can robot, once it got a can, the next thing it was trying to do is, figure out the shortest distance to the goal and to try to get into the center of the goal. And if it hit something else in its path, like another can, it would just knock it over, or sometimes get caught under the gripper, or, those kinds of things. But with this, it seems like you could, once you had a can, you could also do obstacle avoidance. So you could, instead of doing a straight line path, you could actually set it, one of the things you can do is you can give it a kind of an XY distance and tell it to drive there, and it will. And you can also, like, using the little playground thing, you can say, okay, if the distance, continuously look at the sonar, and if the distance gets below a certain amount, turn left or right to try to avoid an obstacle. So, that seemed a little bit more sophisticated than kind of the previous approach. And, it's okay that the robot does that, because, you're only supposed to control one can at a time. So you have to bring the can back, put it where it was. But that certainly seemed a little bit more sophisticated than, just to kind of go find the goal mission and, can't really do anything else. So, but anyway, it looks kind of neat as far as capability. I wish at this point, kind of been banging my head against the wall with things that don't seem to work right. So, but I don't know if they tested a bunch of smartphones, and I don't know, maybe they say that they didn't test every smartphone out there, so maybe there's an issue with mine or something. I don't know, but
what about Android version? I would think that would be a big problem.
Yeah, on this phone, yeah, I'm not certain what the Android version is.
Ray, when you do upload, do you have the IDE open on the phone or from somewhere else?
That's, well, what they say you're supposed to do is open up the app on the phone and, just hold it up and scan the QR code, and it's supposed to load that code into your phone, which that's the one that goes on that's basically the robot controller phone. That may be one of the things. I have there's a Q lens and an AI lens on that camera, and I can scan the barcode, but only when I'm using the Q lens. So, I don't know if that could be an issue right there. I just have 2 LG phones. I don't have any other old phones that are new enough. I have a Samsung S4, but that thing's a dinosaur at this point. So, yeah, maybe if we could. Oh, yeah, actually, my wife does have another phone now. She's got a Motorola phone, but I could try that one and see if kind of load a few apps on it and then see if it works, and then get rid of them before she knows that I loaded some apps on her phone.
Just don't screw it up.
That's right. Yeah, it's like, I don't know what happened to your phone, but
if Google Play said it should be compatible, I mean,
yeah,
you didn't bypass the compatibility check, did you, when you downloaded it from the Play Store?
I don't think so.
What's the name of this thing again?
It's just called OpenBot. So openbot.org, or actually there's a .org and a .com. I don't know why they did that.
But and is that what the app's called on the Play Store?
Well, actually, in GitHub, in one of the README files, they give you a barcode to scan, and you just scan it and it downloads it on the phone. And there's one there's one that goes on the robot, and then there's another app that looks very similar. That is like if you want to make another phone a controller. So,
Can you put a link to the Play Store in there for it?
okay. Well, I didn't get it through the Play Store. I just got it through GitHub.
Oh. Can you put a link to GitHub in there?
Sure.
I mean, I've got developers in India working on telephony apps for us, for my company, so I'm not an Android expert, but I have enough familiarity to be dangerous.
Yeah, I probably have even more dangerous knowledge. So,
well, I think that the chances are, if you're sideloading it through GitHub, then you might be bypassing the normal like API level compatibility checks that are built in.
Yeah,
to Google's fragile distribution center system.
okay. Yeah, the link on these is pretty simple. It's just if you go to their main page, which is just www.openbot.org. And there's a link to GitHub right up on the top of the top of that page. So,
okay, cool.
And then in the listing, there's a folder just named Android, and that's where the 2 QR codes are to download it. Anyway, yeah, so some things work, but it's kind of like I got to get a lot more things working if this is going to be useful. So anyway, Doug, it looked like you designed that board specifically for a future project. Maybe it was OpenBot. I don't know.
No.
But it's fits the build perfectly. It's like,
well, a lot of those small robots have the same requirements.
yeah, that's true. That's true.
Okay, so on that GitHub page, you'll see that they list build the apps under prerequisites, an Android device, and you need a minimum API 21.
Yep.
And the current targets to get out there are, I think it's even higher than 31, 32 in the stores right now, but you need a minimum API of 21. So you can go look up your device model or your wife's when she's not looking.
Yeah.
And you can figure out from there which API level it supports. Because that'll correlate to like an Android 10 or 11 or 14 or whatever.
Yeah. Okay. Yeah, I saw that in there. It's kind of my assumption was it downloaded, it looked like most things worked, and I thought, okay, well, I didn't have to do any of that stuff then. Probably not.
Pretty old, because 21 refers to 5.0 Lollipop, and that's a lot of candy bars behind.
Oh, is it? Yeah. Well, it has to be older than that, right?
Newer than
that. Yeah.
Newer than Android 5 APK 21.
Yep. Yeah. This phone, I think, is less than 5 years old.
But they compile, like the build they do, if they compile with a target API of API 32, so you might need a minimum API 32, which is
relatively new. Yeah.
That looks like Android version 12.
Okay. Yeah. Well, they said that they had several different, let's see. There was a Google phone in there. There was an older LG phone in there. Phone models that they tested, and they said that actually worked. I don't know. There's about 10 phones. I don't know how you pronounce it. It was Huawei. It's one of the Chinese phones. There were some
Huawei.
Samsung phones in there. What's that?
Huawei.
Huawei. Yeah. Anyway, okay. Yeah, I'll check into that and see if maybe my 5-year-old phone is too old. I don't know. But,
Well, cool.
okay. Yeah, and I'm not familiar with anything Android. This is kind of my first,
Yeah,
You're
try and
bringing
think
in, Ray.
if your
What's
phone is
that?
version 12 or newer. See if it's version 12 or newer. I think
Okay.
that would be your best shots.
Yep.
It'll be buried under settings about somewhere.
Yep. Okay. Security pack, base version. Well, all kinds of information here. It doesn't look like anything. Oh, Android version 9.
There's your problem.
Yeah. Darn.
They can make the code compile for that the way it reads in the documentation here, but it looks like they're currently building it. Like if you want to build it from the GitHub repo, which is a pain in the rear to set up Android Studio and do it, I've done it. They would have you set the target to 32, which is Android 12.
Okay.
So that's probably why you're having trouble, and it's not worth your time until you can find a 12 or newer.
And is that a phone old enough that it won't upgrade beyond 9?
Well,
That's
9 to 12 is a pretty big leap. Sometimes you can get one version I've seen.
Okay.
And 13, so they talk about APK 12 and 13. No, they talk about APK 32 and 33, which correlates to Android 12 and 13, which are, I think, 3 or 4 years old by now.
Okay.
If I remember right.
Maybe it's time for a new phone.
Robot would have. I love it, I think, Ray.
I probably would, yeah.
You can get those like super cheap phones at Walmart, right? Like
Yeah, I think
Dollar General.
yeah.
Like these were both under $100 for my work. One's a Moto, low-end Moto. The other's a low-end TCL.
oh, okay.
And they were okay for what they were.
Yeah.
Although they're getting kind of aged now, and I think they might be 12, if I remember.
Yeah, Samsung has kind of a lower end phone. It's not in the the S series. It's something else, and it looks like it's maybe price point wise, maybe similar to those.
Yeah, I guess these are 10s, but I'm pretty sure you can find one for under $100.
Yep. Okay. Well, that's good. Yeah.
Yeah, that's a real good point. I got a Pixel for my mower, and I wonder what version it is.
Which is it? A Pixel 7 or something?
It's a Pixel 6.
Oh, 6. Yeah.
Here's one for $39.99.
Where's that at?
Amazon.
Oh, okay.
So just don't buy it on the 28th because that's a embargo day. But I have no idea anything about the vendor, but
Octa-core. Yeah.
but that's the cheapest I've seen.
Okay.
Here's a Galaxy A03 for $70. Samsung Galaxy.
Okay.
with 3 camera lenses. I don't know how many cameras, but it has 3 camera lenses.
So this is a Pixel 6a. You can get them on eBay for like under 100, around 100, 120 maybe, and it's got Android version 14 on it.
Okay. Yeah. Yeah, Samsung or LG doesn't even make smartphones anymore, so you know this. Maybe it's time for a new one.
I mean, you don't care about screen resolution and camera pixels so much, so you can probably do pretty good in this range.
Yep.
Just don't, I would say if you can, I mean, I would avoid the locked ones or the prepaid ones.
Oh, okay.
Try and get an unlocked phone that's not made for prepaid service like TrackPhone. In my experience, those just give you grief if you ever want to hook them up to cellular.
Okay.
Because they'll basically hack the Android image to keep your SIMs so that you can only use a certain carrier. And when you have a phone dialer like I do at my company, it really doesn't play well in the sandbox by design when they hack the firmware like that. So unlocked phones, no prepaid phones.
Okay.
Save your money on the display, the display resolution, camera resolution, number of cameras, and I bet it'll do fine for your robot.
Okay.
As long as it has the sensors you want.
Yeah, I'm guessing most of them, they're going to have, well, the other good thing is, they've got GPS, so you could use it outside.
Yeah.
And if, you get a decent model, you could use that to detect cones and not have to worry about, things with, light intensity ranges that an OpenMV H7 or a Max, well, MaxCam seems pretty good, but Pixie cams, they can't tolerate, really bright light, and everybody has to stick a filter on the front to get the thing back into a, an acceptable light intensity range. So you can avoid all that stuff because the phone's made to work outside.
Yeah, so you might want a good camera, but one good camera instead of like 3, right?
Yeah. Yeah, it doesn't have to have 3 for sure. Anyway, okay, well, that's good suggestion. Thank you, Carl.
Sure. Good luck. Here's a Samsung with Android 12.
All right. Well, if we're done with Ray, I've got a show and tell. Sorry for the camera moving all around while I screw a tripod onto it. So
About to get seasick.
sorry about that. Okay, so this is, let me just disconnect this power.
It's the Blair Witch Project.
So this is MiniBot, and I've actually been, no, that's a glass of wine.
Sure.
Whiskey. Yeah.
I've been attending a meetup meeting on Lino Robot and AI that somebody hosts on Sundays, and they helped me overcome some of my misunderstandings, and I made some pretty pleasing progress. So this is the ESP32 on the WaveShare general driver board, and it's got a little antenna wire there that comes on over here to the antenna, and it's on my home Wi-Fi, and then the LiDAR, and got an ideal diode here for for running it on shore power so that it doesn't run the battery flat, and an IMU here, and then some TT motors and a battery underneath. So I had considerable success this last week, which I'd like to share with you guys. If I can, nothing to turn it around, look down a little. There we go. Okay, so now I'm going to share a window. And let's see, are you guys, yes, you guys are seeing the Aviz window. And so I'm going to start up a SLAM node. And so this is running on ROS Jazzy. Okay, so I started the SLAM node. And okay, so what we're looking at here, if this thing will just wake up a little bit here. Come on, you can do it. Okay, come on, let's have some LiDAR. Okay, we've got no LiDAR, so let me just restart the serial interface. So this is running, restart the Wi-Fi interface. And a kind of a neat thing is, so this is the Lino robot software stack. And a kind of neat thing is it prints syslog entries from the ESP32 out to a syslog file in my laptop, which seems like a good debugging feature. Okay, come on. Okay, this is working just before.
So performance anxiety again. Stage fright.
Yep. Demo effect.
Demo mode enabled.
Well, it obviously scanned it at least once, you know.
Try.
Is this like a Rorschach test? I mean, I see somebody's logo in there.
Oh, I was thinking maybe I've been watching too many parrot videos, you know, with the parrots on the.
Yeah.
Says LiDAR communication is normal. Why would that not be working? Well, this is it's not getting a transform. I don't understand why, but we shut everything down and bring it all back up. There we go. Okay, it looks like that's initialized, and then you'll be able to bring SLAM up, and that looks happy. And then bring Aviz up, and I think that's looking happier. Yes, that's looking happier. So let me reshare that out. So what we're seeing here, are you seeing the little jiggly lines around where the black marks are?
Mm-hmm.
Yes.
So those are the LiDAR scans. So if I turn off the map, because SLAM created these black lines are detected walls or obstacles that SLAM found. So if I turn off visibility of its map, you can see the jiggly little LiDAR scans coming off of the LD19. And do you see my cursor arrow?
Yep.
So this curved line here is the, let's see, you're also seeing, right. So that would be the corner of MoBot's bumper. It's kind of curved a bit. And it's about sort of ahead and to the little to the left of the robot. So that's what that is. And then this sort of like ziggy-zaggy thing here that's about straight ahead of the robot is the closet, the robot closet, and then next to it is the bookcase. So that's that straighter area there. And then out here you've got the hallway through the door. So you see this line way down here. So that's looking out through the door to the right of the robot. The robot's facing the bookcase to the right of the robot. So anyway, that's the LiDAR scan, and then SLAM made.
Hey, Paul.
Yeah.
Yeah. Why are they different colors? What does that represent? Hardness or?
I believe it's the intensity.
The what?
The intensity.
Okay.
Reflection intensity, I think. I'm not 100% sure, but I think it is. So SLAM made this map, and then what you can do is drive it around and have it map out more of the room. So you can see it's kind of the robot's down in the corner there, and then there's MoBot, and there's an area behind it, sort of like in there, that is unmapped at present. So it's sort of straight ahead and to the left. So that's kind of up in this area. So now I'm going to drive it with a joystick and the old joystick out. And you have to be kind of gentle. SLAM is kind of sensitive. But what you should see here, oh damn, it lost it. See how the scans are now kind of, well, they're still kind of aligned, so that might be okay. Anyway. And if you look at the scan, you should see it fill in that section that's sort of off and to its left, and it did up here. You see some roll dots up here. That's beside MoBot, on the other side of MoBot, and then here's the wall with the robot shelf.
That's cool.
So that's creating a map, and now what I can do is save the map. Okay, so I've now just saved the map, and now I'll exit SLAM and enter navigation map using the map that I just saved. So let me just check where the robot is. Just bring up SLAM again so I can get the robot position lined up, because you have to you have to localize you have to tell the robot where it is. To start with. So I'm going to spin the display around and move it to line it up with this little navigation icon. So now when I start navigation, I'll tell the robot it's here. I've got a kind of a reference, at least in the screen world, as to the current pose of the robot in the map. So now I can turn the map off and back on again, which will mean there's no map because they haven't started publishing it yet. So now bring up nav and bring up its map. And I set the 2D pose estimate, which was right here. And so I'll turn the local map off just to make things a little clearer. So this is the robot looking. Well, there's you can see the rounded LiDAR is the bumper, and it's kind of facing away from the bumper, and you can see it's yeah, it is. It's back off over there. So now we can tell it to drive somewhere and set up a nav goal to navigate to, let's send it down here. And you can see the robot is moving. And it says it reached the goal. You can also set waypoints and have it navigate through them by setting a nav to goal, and let's set one here and another one here, another one here, and we'll see if this will work. This is okay, and then you tell it to start waypoint following, and so it's turning around, heading towards me to the first waypoint. Oops, it lost localization. Now it looks like it might have, because you can see the LiDAR traces are all messed up. They're no longer aligned with the walls, with the map. So I think it may have lost its mind here. And I found that apparently I need to do some tuning here to get this to make it work better. I'll turn on the local map and I'll drive it a little bit, see if I can get it out of its bind. Okay, it just took off now by itself. Now it's driving itself. So it's backing up to the goal point. So it's on the third waypoint now. Now it's going forwards, and it says the goal has succeeded. So it achieved the fourth waypoint.
Wow.
So that, in a nutshell, is Lino robot creating a map and then navigating within the map after the map had been saved. So anyway, that's
Impressive.
So anyway, that's all I had.
So the map doesn't stay stationary. It moves around as the robot moves around. Is that right?
That's a really good question, Ray. And the answer is there are two maps. There's a global map, which does not move, and the local map, which does move with the robot. So this sort of brightly colored one that I can turn on and off like so is the local cost map. Then the global map is this one. And this bunch of green dots is a particle swarm that's attempting to localize the robot within the map based on trying to match it to features it's found. And you can see it's kind of hosed, I believe.
So if
because-
everything were working correctly, would the two maps line up?
Yeah.
Okay.
So as it moves, you'll see the local cost map move with it.
Does it look hopeful for like 5 CAN or something like that? This LiDAR?
That's what I'm hoping to. Oh, there was one more thing I was hoping to show, and I haven't actually tried this yet. So this would be a real interesting test. Tell you what, I'm going to just exit the navigation program and restart it, and hopefully it will relocalize itself in the map. Oh, I'm going to have to give it its pose. Tell it where it is. Where is it? It's over looking away from the bookcase. So that is so the bookcase is over here. So I'll tell it its post is about here. Okay, now you can kind of see the LiDAR scans and the local cost. LiDAR scans line up with the global map. And let me turn on the local cost map. And now the local cost map, these purple lines, I think, yeah, they kind of they pretty much line up with the scans and with the global map features. So the idea of a cost map is that where it's black is infinitely high cost to navigate through. You can't navigate through it. So that's walls and obstacles. And the idea is that the global map is something you record one time and it stays fixed, and the localization algorithm attempts to localize itself within that, and then the local cost map discovers obstacles as it drives, and so if there's an obstacle, that becomes a high cost to try and navigate through. So what I'm going to do now is put a box in the way and try to navigate through it. Let's see. So did we see that controller? Did we see the box come into
Yeah.
view? I can't. Oh yeah, there
Yeah,
it
it
is.
did. And it's funny because it kept your feet where it thinks it saw your feet,
Oh,
which is kind of fun.
Yeah. Okay. So now if I set a goal that's on the other side of the box, it should navigate around the box. And we'll see if it does. I haven't actually tried this yet, so nothing's happening. Why? Oh, nothing's happening. Why? move the box away because there is
Is it?
if stuff is too close.
Do you have to click the start waypoint following, or is that just for waypoints?
Oh, I want to. No, I didn't want to. I just wanted to navigate, not without using waypoints. And that doesn't seem to be working quite right at all. So I don't know. Let me stop and restart the navigation. And it's still got its back to the bookshelf, so I'll tell it it's there. And it's not a real great alignment, but it's somewhat aligned. And so now, can I navigating, see if it'll navigate. Oh, doesn't want to navigate. Oh, why would it not navigate? It was navigating before. Oh. Very confusing. Seems to be stuck. Shut it down and restart it. Well, let me just get a bit of localization. Pull up the SLAM toolbox and get a bit of localization. Uncrypt that. I'm still, obviously, I'm not very familiar with this. To the powers. That's right about there. That doesn't look right at all. It's not right at all. Well, this is turning into a bit of a bust, I'm afraid.
Well, I mean, on the contrary, it's been pretty impressive.
Okay, so SLAM says it's there. So I'll quit SLAM and stop navigation. It should be right there. That doesn't make sense because according to this, it would be right up against the wall. So something's not right here. I'm sorry, I don't know what's not right, but it just ain't right. So, sorry. It did navigate once, but yes, I'm having all kinds of.
Yeah, well, that's really good. I mean, I used that ROS. I didn't use the Navigator or SLAM. I just built my own. But I created a map of the arena wall last year, and it worked out really well. It could using my simpler LiDAR sensors, not the rotating one. It was able to see the walls and try and keep alignment to it to keep its odometry, its direction.
Mhm.
And so I didn't do a mapping because I didn't need to figure out where the walls are, because I knew where the walls are, which was really good for that competition.
Right. Yeah, you had some pretty sophisticated stuff going.
Yeah. But there's a lot of things to try to figure out. I want to try to figure out how to use the actual Navigator software or stack in ROS, and try to avoid obstacles of cans and try to figure out, hey, the can I want isn't an obstacle. Go get it.
Yeah.
So.
Yeah, that's where I'm going as well. And so a couple of thoughts on that. The Sunday guys pointed me to Automatic Addison, who has done a ton of really good ROS tutorials. They're web tutorials, not really videos, but he's got half a dozen tutorials on navigation and SLAM, and I actually was running them last weekend, and you run them in simulation, and it all just worked, and showed me how to. It showed you how to first of all make a map and navigate through it like I just demonstrated, but then how to tell it through an API where to go in the map, which is really what you want for 6CAN. And then the other thing you need is to approach something. And I didn't get as far as that tutorial, but he had a tutorial for approaching an April tag and going right up to it. So clearly the concept there is the same.
Yeah, I was trying to. I remember reading something or scanning something about, like on the outdoor contest, it's mostly about obstacles, and because there's not really a map of the area, but there is a way to run it without a map of the area. And when you start it, then it will build one up on the fly.
Right. That's what SLAM is.
No. I'm talking about during while you're actually doing the goal checking, because basically it while it's running, it'll sort of figure out where stuff is and for avoidance and stuff. But I think that's your local cost map.
So you can actually, I didn't show this, but maybe I can. I'm not sure. But you can actually
not having a global cost map or a global thing, because you don't really care where anything is. You just want to know where things are at the moment, and there's nothing fixed that you can.
Right.
Man. Yeah.
Right. And you can use the SLAM algorithm that way. So let me just reshare that and show it. I think it's going again.
Yeah, because you have GPS on the outdoors, so you pretty much know where you are and what direction you're pointing.
Right, right. So you don't have to set an initial pose with SLAM, because SLAM is making the map, as you say. So with the SLAM system running, you can put in a nav goal and ask it to drive to here, and well, when I did it on the weekend, it actually did drive. So I don't know why it's not driving there.
Mhm. Yeah, I've actually run the TurtleBot sims using navigation and Slam. It's pretty fun to go through those tutorials.
It's still accumulating waypoints. It was still in waypoint nav through poses mode.
Oh,
That was the problem.
reset it.
Yeah.
Yes.
Okay, so now let's try that again and see if it'll navigate somewhere. Nope. Huh.
It's yeah.
It was. I
It's,
promise on the weekend it was navigating.
it's tired of showing off. Yeah.
Deciding not to. Oh, it might be. It might be too close to. Let me just drive it forward a little. Apparently, if it's too close to a wall, it won't. It won't start. The collision. It's got a collision detector that will prevent it from starting. So I'll just drive it.
There's all kinds of fine tuning you're gonna have to do. Yeah. So I can get to a can close to the wall and everything. So
no, that wasn't it. It's far enough away now. So
all right.
yeah. I don't
Well, next week I expect it to work perfectly.
I should be so lucky. Yeah, so anyway, there you have it. It's a partially successful demo, but anyway, I figured this is sort of like the basis of what I propose to delve into more depth in a March monthly talk.
Mhm.
Okay, well, we'll stop presenting and.
So that LiDAR unit, it's pretty much self-contained. You don't have to control the rotation speed. It does it automatically and just spits out data.
Yep, it's
over a serial link.
It's just runs at 10 scans a second, and there's only one of the weaknesses, I guess, of the general driver for robot board is it doesn't have an outbound serial port connection, so it actually can't drive an RP LiDAR because RP LiDARs require giving the LiDAR a start motor command. So this thing just starts up, and it says it's got a direct drive brushless DC motor that spins the head and claims it's good for 300,000 hours or something crazy. And it's small and compact, so it's kind of a nice little unit. And I think it's let's see, it was $60. So pretty decently priced.
Yep.
Yeah, I was looking at its information, and it has 4 wires and has transmit only, no receive input. Yeah, but it does have a PWM input. Interesting.
It does have a PWM input, but it doesn't have to be driven with anything. If it isn't driven with anything, then it just free runs at 10 spins a second. So actually something I've been meaning to update, and this is probably as good a time as any, is this parts list, because there are two things that you don't need, that I don't have here, the Oak D-Lite and the Raspberry Pi, because I'm going over Wi-Fi straight to the laptop. So I'm going to put them as delete them. And so that leaves me with a build cost for the robot of $134, which is, you know, some motors, some wheels, a waveshare board, the LiDAR, a battery, and an IMU.
Maybe a little PLA, you know, a couple meters of PLA.
Yeah.
Or did
Yeah. What should I put in 10 cents for that?
I don't know. Yeah, it seems like filament's gone up quite a bit, but
Yeah.
so that was an RP19 or an RP10?
LD19.
LV19.
Yeah. So actually, let me go back to sharing. Oops, that wasn't the one I wanted. LD19. Okay, so let me get a wave share. Wave share. Wiki. Here we go, LD19. So this is it. I can stick that in the chat. And so the main things are it's got TOF ranging, claims 30K lux anti-glare. So that would be not full sun, but reasonably bright. Anyway, there it is. It just free runs at 10 hertz. Pretty nice little LiDAR, really. So there's the PWM motor control signal, which if you don't feed it then it free runs. And interestingly, it's apparently got a, maybe they all have this, I don't know, but it's got a wireless transmitter, I think, in the head that transmits the signal down to a radio receiver in the base, as best I can tell. And then it's the output of the radio receiver that comes out on the serial pin.
Yeah, I was measuring my RP LiDAR, and it's about the same size as the LD19.
It's not. It's a lot bigger. So I've got Mark's.
Yeah, because
let me just see if I can get back to the.
it's about 54 millimeters square, and
Yeah, the C1's pretty chunky.
40 millimeters tall.
You can see they're pretty big difference in size.
Yep. It doesn't have the cool blinky lights either.
Yeah. Anyway, and I guess height-wise, the RP LiDAR is a little taller, but not much.
Okay.
Yeah.
Interesting.
Yeah. So Anyway, fun times in the robot lab, getting the thing to drive itself around. Just got to do some more tuning, and I got to learn how to tell it how to use the API to tell it where to go and how to approach things like cans and April tags and such. And once it can do that, then in theory, it should be a matter of getting a grabber and then you grab a can and tell it to go back to the goal. And it should avoid other cans on the way because that's what it does.
Easy peasy.
We'll see.
Yeah.
That's cool.
You know, Scott's
All in
always
as little
giving,
time as possible.
Scott's always giving the rest of us grief and you know, dishing out the smack, and so I might need to dish out some smack back to him.
Yeah. Yeah.
Well, that's all I had. So let's see. Carl had something to tell us about AHA.
Yeah, give me just a moment to get one thing done here. Just a second.
And I guess while Carl's getting ready, is there anyone else that I didn't get in the queue? The one to talk in the queue? Ted?
I'd like to get in the queue, please.
And Michael, were you in the queue? Wanted to be in the queue? No, just Ted. Okay.
I got something I could share real quick. That,
Okay.
a work in progress. See my claw machine in the back there. Back of me. I guess I could present it. I'm going to have it pretty functional. Let's see. There it is. It's presenting now, isn't it?
Yep.
All right. It's my claw machine. It's going to have a turntable, which I think I've showed some of y'all. This turntable is going to go down here, and the claw machine, like you see in an arcade, and the toys or whatever are going to be on this turntable. But I got
Michael, I think you're not presenting what you think you are.
What?
You're not you're presenting your screen, but it's just showing us the.
I don't know what's going on.
What are you trying to present? I mean, we see your video. Is that what you wanted to show?
I wanted to show our back of my shoulder there. Let me stop presenting. I'm just presenting. Let's see.
Yeah, we could just pin you.
Yeah, just pin me. Pin me.
Yeah.
That works since I don't know what I'm doing. But okay, you see it over there, right?
Yep.
Yep.
Hold
Oh,
on.
that's the crane thing. Cool.
It's a claw machine. I'm trying to get the present off of here. Hold on a second. There we go. Okay, y'all can see me, right? Y'all got me pinned?
Yep.
All right, there's going to be a turntable that goes right here. And this just goes in and out like a crane, you know. Claws right here. And I still got wires hanging, but anyway, I got it working. I've been working on the code, and I got one more limit switch. It's pretty much worked off the limit switches, and Arduino. Anyway, I'm going to present it now. I'd like to maybe if I get it presentable, I might want to show it off at the maker.
Oh yeah, yeah, that'd be awesome.
So anyway, it goes in and out. Of course, you can see that, right?
Yeah. People love things they can play with.
Huh?
People love things they can play with.
I know it. And then you'll see the turntable. I'm going to rotate this. I got 2 stepper motors in here. I showed y'all a few weeks ago that I put 2 stepper motors in there to relieve the chatter of of the acceleration, because you got a lot of when you put the table on here, put stuff on it, you got a big load that those stepper motors are trying to pull. So anyway, that turn, that's you set. Can you set turning down there?
Yeah.
Okay, the table's going to be on that. All right, so I'm going to pick up this. I'm going to pick up this little elephant. It goes in and out. They can turn the turntable and pick their item, and then it'll be on a joystick. This will be a joystick, and then I'll push a button. And it'll pick it up, take it over there, and it'll unload it.
Love it.
So that's where I'm at with that. So
All right.
That's excellent.
thank you. That's gone through about 50 iterations. I don't know. A couple of years ago, or maybe a year ago, y'all saw me jacking with a geared arm. It hit in the hell, man. What a mess. But anyway, this ended up what it's going to do. So, and the turntable, huh?
I think that deserves a gold star. Like
Well,
we saw things moving.
thank you.
Yeah.
Yeah, your robot moved tonight too, so
Yeah.
we'll have to split it. But they can control that turntable any direction, back and forth. And so this will be stationary, and it'll be a lot of fun. I thought it'd just be a little different than most claw machines you see out there, and it's different than what I've built before. So it'll be unique. I'm going to put some bells and whistles on it, some LEDs and stuff. So there we go.
Cool.
Thank you. Yeah, I'd like to try to share that on that, if I get it looking presentable on that Saturday or whatever.
Yeah, that'd be awesome.
All right.
You.
You bet.
So do you have like an acrylic box that the whole thing sits in or something?
These are good. I've got a box from my old claw machine, but this is a Lexan, and it's gonna be on the turntable like this.
Oh, okay.
So they'll be able to see it, but I'm gonna also have a barrier from my old claw machine, a Lexan barrier that'll keep it from sticking their hand in there. So I might even have to make a little door for when I drop the prize, that the door will open with a little servo motor or something, so that they won't be sticking their hand in there while it's turning. Because I'm gonna cut out a part of that. I'm gonna section off a part of that turntable to where I can just drop the item in that part of the turntable. It won't have any. So that's what I'm planning on doing. But yeah,
So no high voltage wiring or anything, huh?
I'm making it 12 volts. I'll tell you why. Because I go to these Halloween carnivals, like church carnivals, and if I don't, I'm gonna make it 12 volt this time, so that I can use any kind of car battery or something. So I don't have to worry about setting it up by some 120 outlet, which I've had to do in the past.
Yep.
So it's going to be running off of 12 volts with probably, I'll have to put a buck converter on there for the servo motor on the clamp and all. But it's going to be running 12 volts on the motor. Is that what you were asking, Ray?
You're muted, Ray.
Huh? You're muted, Ray.
Ray, you're muted.
I was just, wondering if you were going to stick some high voltage wiring around the outside edge to keep little hands from
I should have known better.
reaching in there.
That would be the funnest part, wouldn't it? Watch the little kid go.
That's right.
I'll think about that.
Just low current, so
Cool. Thank you, Michael.
Yeah. Next
Oh.
week I should have the turntable on there with some junk on it.
Oh, yeah. I mean, I love to see that. I mean, love to see stuff moving, right?
I do too, man. And yeah. And I keep my code real simple because it's a lot faster. you know, and you get things moving a lot simpler, a lot faster than. I was just making a joke. But anyway, go ahead.
Okay, shall I jump in?
Yep.
All right. So this is kind of a club related thing, and without getting into ages or location, I'm going to show you something that I finally started catching up with some old magazines in the living room last night. And I noticed this ad that I hadn't seen before in my February of 2024 Model Aviation magazine. So it's RC Modeler thing. And it gives you an idea of how far behind I am on magazines and everything. So so this caught my eye. Fly into a free membership with your health plan. What? It says eligible Medicare Advantage and Medicare Supplement reward members for staying socially fit to their passion for flying. I thought, huh? That's interesting. So, I mean, I'm not yet in Medicare, probably in some years, but way too few years probably. But this had me wondering, what on earth is this grouper thing? And Element 3 Help, what is that all about? So I did a little search, and this is what came up. And okay, say what you will about the lifestyle photo, and try not to look too funny at the benefits with friends tagline. I mean,
that's a little edgy there, Carl.
No, this was a
Edgy.
That had to be intentional.
Yeah, I think it was
What kind of
friends
robot
with
Zoom
benefits.
meeting is this?
I mean, to combine. Okay, anyhow, all right. So the gym isn't for everyone, and they have gardening, dance, walking, games, golf, arts and crafts, bridge, and more. So how it works. All right. So I looked around a little bit, and I don't know. It looks like you can actually register your club here.
Are we going to get an old folks robotics thing going?
Well, so I don't know. I don't know what's involved. This is the only thing I see. It's an Airtable, so it's like a Google form, a different vendor for that. And it looks like you can register your group here somehow with not that much information. What's your passion? What's the name? I mean, if you have a Facebook page, yeah, good enough for us. Leader's name. So total size, and then how many 65 and over do you have? So the best I can tell, you know, all it does is these health plans have encouraging incentive to join a club so you can stay socially, mentally, and physically fit. And that includes memberships and things. So like here they are knitting, right? So why not do DPRG? So I was wondering, it sounds like I didn't read too much, but it looks like you get to you pay normally and then submit for reimbursement. But if you're eligible, then it looks pretty straightforward. Like AMA set up their own page here, right? They have modelaircraft.org/grouper. So they have their own web page to check your eligibility. But anyhow, I just wanted to bring that up. And if there was enough people, I don't know what enough is, who would want to get reimbursement for their DPRG membership. I thought one of us could try and check this out. And if there's enough interest, why not, hey?
Yeah.
I think I probably owe a membership fee or two, so I might handle that up the next couple of days. Thanks for the
I see one thumbs up. So several. Okay, so there's enough thumbs up. So then it's just a question of who wants to chase it down, and I can chase it down. But I'd put. I can even be the contact member for now. But if a board member wants to do it, I wouldn't object either.
So does it include beer drinking as an activity, or?
We should try a club like that.
I mean, like our social events, yeah. Like
Club
our
activity.
Power lunch, yeah.
We're the keggers.
I thought I looked through that thing when you sent it out, Carl, and I thought I'll give him a call and find out, like if it might make sense for DPRG. It seemed if I understood correctly, if the DPRG were a member of this program, then those of us who are on Medicare and have a supplement would be able to get their DPRG annual membership refunded. I got that right?
I think so.
So I can give them a call and find out, if we're a organization that would make sense.
Okay. Well, they have that sign up form. I can put the link in for that too. And I mean, even if it's not DPRG, for anybody that wants to look, this other page, the link I put in, I mean, it could be that you can find whatever other kinds of clubs too. So maybe there's other ones. They seem to be able to find ones by your zip code. So
yeah. I'll see if I can contact them and maybe even register us, depending on what I find out, and report back next week.
Cool. All right.
Thank you for bringing that to our attention, Carl. That'd be kind of a nice DPRG membership benefit for those of us in the more senior category.
Well, I'm probably not alone in saying I'm all for benefits with friends.
Not touching that with a barge pole.
Yeah, let's not flip that around either in this group. That'd be trouble.
Or any other kind of pole.
This isn't the Villages.
Okay, moving right along. Ted was up next.
Okay, so Carl, you and I are on the same wave here, because I was cleaning out my bookshelf this weekend and found some old magazines. One of them, a Servo Robots magazine from 2013. Something caught my eye, so I opened it up and found this article, and look who that is.
No way.
I remember that.
Yeah, self-driving cars.
That was with Jason.
Yeah, J Rover.
Yeah.
Wow.
So,
That's
we
impressive.
actually competed J Rover in a Robo Columbus.
okay, cool. That was
Wow.
before my time in this group.
That's cool. Thank you for sharing that, Ted.
Yeah. So I have another article from 2013 also. This one's not a magazine, but I'm going to share my screen. Let's see. Where are we? Window. Yeah, let's do this. All right. And this is related to using cell phones to drive robots. So this guy way back in 2013 had this robot, and he used the Android phone for the brains of it, and then had these other sensors hooked up to it. But yeah, apparently this has been possible for a while. He has a whole list of everything he used along with the cost. And he had the phone as 0 because he had a donor phone for it, I guess. But yeah, I thought that was kind of cool. And I think he just used Bluetooth to connect the phone to the sensors and motor controllers. So I will post the link to this. And if you're interested in cell phones and robots, you might check it out, because you don't really have to worry about how old your phone is if you do it that way.
Yeah,
So yeah, I just put a link in. And yeah, he got some impressive results here. Let's see.
BPV.
Yeah, there's the phone, and he's hitting start, and there it goes.
Ripping right along.
Yeah,
Wow.
I didn't even think he had GPS or anything. It was just odometry and a compass.
That's a big Foursquare, huh?
Yeah. This was for the Spark Fun ABC contest.
All right. The Zivvy.
Maybe finding its own way in the world there. I don't know.
Yeah, it looked like it wasn't going to come back.
A little bit of ringy on that corner.
Yeah. Yeah, I found when I was doing this, getting the corners nice and tight without ringing is harder than you'd think.
Huh. Would you have the same like steering damping factor for the sharp turns as you would for moving quickly through the straightaways?
I don't remember.
I bet you that would make a difference, you know, because you're going, when you're moving along in the straightaway, you're going pretty fast. So it seems like you'd want one set of PID values as opposed to you have to slow down a little bit to change direction so much. So maybe if you had a different set of damping factors for lower speed.
Right. Yeah, that would make sense.
I was thinking to, you know, if I ever, when I get to the Robo Columbus, I had in mind to try and play with the adaptive, is it adaptive or whatever PID loops? Because the one Arduino library, it makes it easy to change the PID values while it's running.
Oh, right. Yeah, I've used that one. That's a good library.
So I was going to have a couple different, at least two different sets of PID values depending on the velocity range.
Okay. So then my third thing was I found this YouTuber who found a $60 GPS module on Amazon, and I actually found it, and it's $70 now. But and apparently it's actually works, which surprised me for $70 that you could get a RTK module that works.
That's also wave share. I have one.
Oh, okay.
Does it work?
Haven't cracked the box yet on mine.
But yeah, this guy got it to work.
Sorry.
Wow.
Question, did he have to have two, or was he able to get a base station locally?
So no, he used a local base station. He didn't have to set one up himself. What did I do with that? There it is.
It is a little different from because it uses L1 and L5 only. So it's a little different from the ones we've been using.
L1, L2.
Yeah. So that means you need an L5 transmitting correction source, I think.
Yeah.
Okay, and the last thing on my list is more experiments with GPS. So I found a straight sidewalk near my house I could walk along, 200 feet in length, and I was walking fairly quickly. I think I got up to about 6 feet per second. So I started at the top up here. No, I started here, walked down, went over to the other side of the sidewalk, and walked back up. And, you know, it's zoomed out away, so it's kind of deceiving how far off it is, but it's obviously a lot less than, well, something less than 10 feet, probably like 6 or 7 feet off. So I thought that was fairly impressive. I mean, that's about what you get with GPS. But yeah, and so the other part of this is this is the heading information I got from the GPS, and I was walking 150-degree heading, turned around here, and then 180 degrees back, which is like what, 330 degrees. And so, you know, it was looking at the raw data, it was bouncing up and down about plus or minus 2 degrees. I think it got off a little more than that here, but yeah, that's what you can expect with going about 6 feet per second. Then I put the GPS in my car and drove at 40 miles per hour, and it got down to about 0.2 degrees plus or minus. So it's very speed dependent, obviously, what sort of heading error you get. And oh, by the way, the velocity error was around 0.2 feet per second, regardless of how fast you're going.
That makes sense.
Yeah. Yeah, anyways, I've come to the conclusion that this is probably good enough for what I want to do it for outside driving. And my plan is to keep the gyroscope and probably ditch the magnetometer, but just use gyros and the GPS heading and do some sort of either Kalman filter if I can get that figured out, or a complementary filter.
Cool. And what sort of robot are you thinking of putting this on?
I'm putting it on an outdoor robot, one with either 4 or 6 wheels. Well, probably put it on both of them. I have a couple different robots, but yeah, I've got the 6-wheeled robot. It's kind of in pieces right now, but hopefully I'll get back together soon. And I don't know, it's like, yeah, about 18 inches wide and 24 inches long.
Cool.
Skid steer. Yeah.
So one thing I don't quite understand, Ted, is you've been investigating the accurate heading accuracy that you can get out of GPS.
Yes.
And so kind of independent of position accuracy. So how does that play into why is heading more important to you than position accuracy?
Well, yeah, I'm not saying it's more important, but I'm looking for a way to get a reliable heading without using a magnetometer, because magnetometers are just, in my experience, all over the place. And gyros drift over time. So I want something that, you know, will keep the heading within some sort of bounds. And so that's why I'm interested in this. And really obviously the position and the heading are related, because if your position goes off, your heading's going to go off also.
Yeah.
But so, and I intend to use both.
Okay. Thank you.
Yep. Yeah, any other questions? Okay, cool.
All right. Well, I think we reached the end of the queue, so let's throw it open for
Paul,
open mic.
Paul, I wanted to show something.
Oh, sorry, Doug.
No, this is just going to take a second. You guys know, you saw it at the January meeting when we were doing the different camera presentations, I showed a robot, and this was one of the wheels that I had on it. Okay. But I told everybody I wasn't really happy with this wheel. And by the way, Dave, thanks for the idea about the bigger pulley. That's going to be incorporated. But I found it. I found the wheel that I want to use. So to give you a relative feel for that.
Whoa. That's Studley.
Yes, it is. And it's a 1/8 scale wheel. It's they're $15 a piece. So, you know, they're, as these size wheels go, that's actually a pretty decent price. And it has a 17 millimeter hex in it. So all my shafts that you see on these are 8 millimeter. So the question was, well, is that going to be a pain in the butt? Turns out you can get these little brass fittings. Let me go see. Can you see this? Can you see it? Little brass fitting. 8 millimeters.
Round shaft. Yeah.
8 millimeter round shaft. 12 millimeter thing. So what you need is the next part, which is this little cap that goes on it, which fits on the end. Let's see if I can do this. Ka-chunk. It looks like that. And then the wheel fits on this. So really pretty straightforward how to go from an 8 millimeter shaft to one of these.
Is there like a through screw that holds it all together or something?
Yes, right here. There's if you look at this black piece, you can see there's a little round part that goes off that fits into the wheel, and in the center of it you can see there's a screw hole. I believe it's a number 5 millimeter. So anyway, turns out that hook it up to an 8 millimeter wheel shaft isn't really going to be a big problem. So I think I've got the solution for that particular robot. I've got the improvement that Dave Ackley got me, where I was losing torque because I didn't have a big enough pulley on the wheels, and then I have this, which will give me bigger wheels. So I think I can settle in on, and I added, and you saw that at the January meeting, I guess it was, that I had put in some belt tensioners. So I feel reasonably good that I can finish this robot now. So, okay.
So what's the diameter of those wheels, and are they kind of squishy?
They're squishy. I mean,
oh wow, yeah. So is it like a foam filled?
yeah, these are like RC wheels, so they're foam filled and the hubs are glued. So, you know, not that I don't think I'm going to be testing that glue, but you never know. So,
so what is the diameter of the wheel?
Really, I knew you were going to ask that. I think it. Give me a second. I'll tell you in a second. I'll go get a ruler.
Oh, okay.
While Doug's off getting a ruler, Ron Grant left this thing. Okay, Doug's back.
6+.
Ah.
6 inches and some change. So anyway, that's what I was looking at, and that was what I was looking for. But every time I looked for them, it was like, $60 a piece. And I could say, no, can't do that. So anyway, they're on Amazon. I'll put a link in a chat. Okay, that's it. That's all I had to say, Paul.
So
And
Ron,
I have a quick one.
Ron Grant left this thing at the with me. This is the knee for Roby the robot, and I just want to like throw it out for ideas as to when might make sense to and how we ought to go about putting him back together and trying and testing him and maybe leaving him partially assembled. So Mark and Mike and Doug and myself, I think, are interested in trying to put this thing together. So anyone got any thoughts on like times, days, evenings, weekends, when we should do this?
I'm not sure about
Well-
days in particular, but weekdays are okay with me.
Weekday evenings or weekends. Yep.
So did Roby have bad knees? He needed,
Yes, yeah,
knee surgery.
And there's various other bits and pieces that are big things that Ron left. But weekdays would have to be evenings for you, right, Mark?
I'd much rather do it on a weekend myself.
Weekend?
Yeah. I got the 9 to 5 to deal with, so evenings
Yeah.
or weekend, yeah.
Weekends are good.
Do we prefer a Saturday or a Sunday?
Saturday?
Sunday? Did you say Saturday or Sunday?
Saturday? I mean, I'm
Saturday?
easy.
Yeah, Sunday around noon, I think, would be a good time.
I can do Sunday noon. Yep.
Yeah.
Yeah, Sunday's
Mike?
good.
Cool.
Yes, Sunday. Mhm.
Now this Sunday, I'll be busy.
Of course. Yeah.
We have committee meetings at DMS, so this Sunday, but any other Sunday would be great.
So what about Sunday? We're at the 25th at the moment. What about Sunday the 9th?
That I'm going to have some things that weekend, so I can't do the 9th.
Okay. Maybe we should do this offline in email.
Well, I think we've solved it. It's a Sunday,
Yeah.
and we just have to pick one that we're all available.
Yeah, let's start this Sunday if we can. Then start Sunday 2nd at 12.
What's that?
Sunday 2nd at 12.
Sunday 2nd at 12.
That's this Sunday.
Yeah.
Oh,
I can miss a couple meetings.
That works for me.
My calendar is open.
Doug?
that's good. I can handle
All right,
that.
let's declare. Let's meet at the Makerspace at 12 on Sunday, and we'll assemble Roby and decide what we're going to, if we're going to like. I'll bring my truck so I can cart him somewhere if I need to, and
Yeah.
we'll decide, assess what needs to happen. All right, great. Thanks,
Okay.
guys.
Good.
All right,
Wait for Mike to catch up. Are you good, Mike?
Oh yeah, I put it on my calendar.
Okay.
All right.
Dave, actually, I have a really quick one when you get the chance.
I think we're there. I think your chance is here.
You muted yourself, Dave. Dave, you're muted.
Okay. These cables I've got mounted on the door, that's tie rack.
It's what?
It's a tie rack. a rack
Oh.
for ties.
Oh, okay, good.
And it has roughly a 4 to 6 millimeter spacing between these nubs, and each rack has 20 nubs on it, which means you can put about 18 cables on it.
Can you put the link in the chat, because that I know somebody who could use something like that.
Okay. Let's see what I can do here.
Yeah, mine are just looped over an open drawer.
Mine's in a bucket, or
Mine
2
are just
buckets,
a bunch
or
of
3
coat-
buckets, maybe even 4 buckets. I've got to do some serious cable cleaning.
Okay.
I don't know where mine are. I
Huh?
can buy them and they disappear.
Yeah. Well, that's one way.
Well, they're on Amazon for 16.55 per strip.
Mine are
Okay.
wherever my socks are.
Yeah.
That's also a mystery.
Yeah. That's sort of where I was.
Yeah.
That's kind of unusual, Kareem. How did that happen?
Okay, I put the link on there. That's the Amazon for those tie racks.
Okay. Great.
Yeah, Ray, I really don't know because I don't put my wires in my dryer.
But I stumbled on that, and I found that was a great way to deal with them wires.
Yeah, that is a good idea.
That's all I had.
Yeah, IKEA has a really cheap, it's meant to go on kind of like their version of a pegboard. And, it's got little hooks that hook into the slits that are in the pegboard. And I can't tell you how many times I've gone to IKEA and looked at it and said, nah, I think I could 3D print something better. Still haven't done it yet, so.
I considered 3D printing too, but the thing that stopped me on it was the fact that the way you would print this, those nubs would fall off really fast and really easy, whereas this is pretty sturdy.
Mm-hmm.
I don't know if that shows up or not. Just
yeah.
So I'm not really too lazy. I've just installed the OpenBot app and the controller app on my it turns out to be a 9-year-old Android 6 phone. They installed just fine, and they seem to be opening, even though they're not hooked up to anything. So that's at least one step forward.
Yep.
That's Android 6.
Okay.
We'll see once I hook it up to a chassis, whether it'll control anything.
Yep. Cool.
The install went very, very, very easily. I just scanned the QR codes that are on the GitHub website.
Yep.
And they just installed. They are side loaded, so there may be no checks, but it seems to be working fine.
That's good. Yeah, I think were you able to hook up your controller to the other robot relatively easy, or?
Well, I have a box full of these things of various types. So I dragged out several and put batteries in them, and they light up. But that's all I know about them.
Oh, okay.
I have some work.
Yeah.
I don't even know if they're Bluetooth or proprietary RF.
Yeah, mine had a dongle, and I was able to with an adapter plug it into the USB-C jack on the phone. and it seemed to work fine. But I don't know whether that was is it a Bluetooth dongle, proprietary,
Yep.
Who knows what it is. So it doesn't say anything in the documentation.
Anyway,
But yeah.
I still haven't got power on my line following robot that I've been slowly putting together. Lots of real life activities this past week kept me out of my workshop a lot. So
Yep. Yeah, there's the little adapter and same sort of thing. So these for me aren't that easy to use though. They seem a little kind of jerky or twitchy, or I don't know. Maybe I was just never a very good gamer or car driver with a joystick.
I've never been a game player with these fancy game controllers. I have half a box full of cast-offs, and I noticed I converted one with an I2C interface, although I can't recall ever having been successful at using it. So I'm just a real old school analog joystick kind of guy where it comes to use.
Yeah, I actually did one with Laura. Kind of a dual joystick that works pretty good.
So I guess this OpenBot project will come a little higher on my list because it just got a whole lot easier. I took a couple of steps and it only took 5 minutes.
Yep.
We'll see.
Yeah, there's my little Laura controller. I had a display on it so that looks like the battery's dead.
When I was playing with my Tribot robot, the Wowie robot, with the funny wheels on it, I implemented a joystick for manual control, and I dug out my simplest joystick from my joystick box and hooked it all up. And it's got to be a 40-year-old Radio Shack joystick. And I held it up and said, "This is what I'm using to control my robot." This is in the Vancouver meeting. One guy in the Vancouver meeting started to laugh, reached over beside him, and pulled up the identical unit from his junk box.
There you go.
Not so old school.
Yeah. This one had it had a LoRa transceiver and a little OLED display, so I could, and I put basically a calibration switch so I could zero it out when they were just sitting kind of in the neutral position. Because it seems like they would never come up exactly at half the voltage that, just at rest. So, but they work pretty good. LoRa goes for a really long distance, so that was kind of handy.
Well, on a different subject, I stopped after the meeting on Saturday. I stopped in at the Salvation Army to look at their collection of suitcases and for holding Roby the robot. And you can get suitcases there for $10 or $15, depending on how beat up you're willing to tolerate them being. So I think that's a decent way. That's a cheap enough way to store Roby's parts and keep the dust off of them over time. And
yeah, I've got I'm not certain what it was used for, but it's it's kind of it's a rectangular case. It's kind of orientated vertically, and it's got 4 pretty heavy duty casters on it. It looks like, something you'd see at a Taylor Swift concert to haul whatever, but it's been sitting in my garage holding small wood scraps forever. Should probably take a look at that, maybe take some pictures of it, see if you want it. So
yeah, measure its inside dimensions.
Yeah, it's lined with pretty thick foam, black, like black foam.
Oh, nice.
So don't know what it was used for, but
Yeah, if you want to shoot me some dimensions, and that'd be great. And Mark's got a big suitcase, so I think we can pretty inexpensively find some way to hold Roby and cart him around between locations.
so what moves on Roby? Just his shoulder and his elbow?
I think he's got, I think his two arms move differently. I think one rotates like that, and I'm not sure about the other one. But I think that's about it.
No, he's got one. Okay, give me a second here. One arm can move any direction. Like it's the shoulder moves. The shoulder moves. The elbows are both elbows are posable, and the wrist rotate. Okay, there's just a motor. All it is just a, I can't remember if it's a servo motor or what. It continues, and it just, all they do is these little grippers just rotate completely. So you can pose one arm, the other arm can do all sorts of movement. I don't think either one of the elbows move. They're locked. Okay.
Mm-hmm.
So
well, you might not be able to get him to twerk, but maybe you could get him to do the floss, you know.
Well, the idea was that he would wave or something. That was the intent. The real intent was to get both shoulders going. But when you see the second, you see when you see the mechanics of the first shoulder, you kind of like go, God, how did anybody build that? I mean, it's a work of art, you know? And so anyway, we're never going to see the second shoulder unless we do something like what was proposed, where we make another robot and make 3D print a lot of it, because he's pretty heavy, you know. So you know, if you wanted to make it a project, you could animate more of it, you know, but it would take some work.
What's he made out of?
He's
3D printed parts.
Okay.
Acrylic.
If you look at the waist and the chest, they start off with a laser cut, I want to say 1/4 inch or thin plywood, and then it's all skinned with I think it's made out of ABS, but it looks like a bunch of straws stuck next to each other. Okay, it's
it's like plastic corrugated cardboard kind of thing.
Yeah, right. It's very light, and so the skinning is pretty light. And I want to say the arms and stuff are actual thin wall PVC. So, and then there's a lot of 3D printed parts on it, and some of the rounding of the corners and stuff was done with some molding that was available. Yeah, and then the base was something that was made. Oh God!
There we go. Here's a video.
Yeah, who is that gentleman that's sitting right in the front?
Is that Will Forte?
Will. He was the shoulder builder. Okay.
I don't know if his last name is Forte or not, but that's what it comes to.
I don't think it was Forte. It started with a K.
Kunkel.
Yeah, that's right. Will Kunkel.
Yeah.
Kayla and Kaylee.
So you can see the elbows or arms, and one arm is posed.
I thought it was
And,
Kunli.
Or Kunli. There you go.
yeah,
We're getting there.
but it's you know, but when it's got that really nice DPRG sign that was made and put on the chest piece, and so I mean, like, it's like a big sign. It's great for like putting on the edge of a booth. You know what I mean? I mean, because he stands up way higher than the people, and he's anyway. Kids love him.
And we're big kids, right?
Right. Yeah. Well, you know what it was? That was done when I was president, and we were looking for a project, and I said, well, why don't we build a 10-foot robot? And I threw it out there. I wasn't really thinking anybody would jump on it, but Will jumped on it. Will jumped on it, and yeah. God. Well, anyway, before we knew it, we had one. So even Jason was in that, Paul. Jason worked on that. He did some of the programming of. It was supposed to be a really early AI, or otherwise when somebody talked to it, it was supposed to give sort of intelligent responses, but it never worked really well. It was more like random responses, So anyway.
So whatever came up on the magic 8-ball.
Yeah, right, essentially. Yeah. But like I say, when it worked serendipitously, it was fantastic, because I mean, whoever was in front of it, when it said the thing that they were kind of expecting to hear it say, it was like they were just shocked. It probably would have been better if we'd have had somebody behind the curtain, if you know what I mean, just kind of observing and just saying things to the kids and stuff as they came up. Anyway.
Can't hear you, Tom.
That's better. I'm trying to be polite and not leave my microphone on. The smallest ESP32 I bought, it's an ESP32C3, but I wanted a little tiny one, so this is the first one I picked up to play with. I was going to put MicroPython on it just to test it out and make sure it's working. And even though you can see that out of the mailbag, it seems to work fine, but I'm having a heck of a time downloading the MicroPython firmware to it through Thani. It doesn't want to do that. So the alternative is to run the Espressive ESP tool to download it. And that's the path I'm following now. Earlier this evening, I installed ESP tool on my Windows machine, and I have no idea where the hell it installed. So I'm running a search for it now. It all has to run from a command line on a Windows machine. So we'll see if I can install MicroPython. It's supposed to install, but we'll see. Not with Thani, apparently.
Wow, that's itty bitty, Tom. How many IOs does it have?
Yeah. To take my glasses off so I can see it.
Maybe 14.
6,
I
7,
can't
8,
install
6.
Tom. I installed it on mine, Tom. You can't get MicroPython on it.
One too, Mark.
So did you install it with ESP tool?
Yeah, with the ESP IDF. Yeah.
Yeah. Okay. Then I should probably work. This brand is a 10-star robot brand. It's supposed to be fine, but we'll see. It's got 18 pins. So assuming 2 of them are power, then the rest are IO.
Mm-hmm.
Wow.
Yes, it's really tiny.
Yeah. I got a pack
Now,
of 2.
the C3 is just a single CPU core. So it's not the same as some of the more powerful ones like the S3, but it's still not bad. And it was pretty cheap. So
yeah, you kind of wonder how many things are actually written to utilize the second core, probably
True.
not that many.
the wireless does. A lot of systems
Yeah.
that use the wireless on an ESP32, the wireless occupies the second core.
Yep.
So we'll see how it goes.
Yep.
Another toy, another shiny thing.
Well, did we run out of robot stuff? And call it a night?
I think so.
See you next week.
Yep. Maybe,
All right.
maybe next week I'll have my line follower running. We'll see. Good night, folks.
Hopefully.
All right.
Good night, everybody.
Good night, everyone.
Bye.